So here we go, we're going to use the quadratic formula with a second equation. This time I've got y equals negative x squared take 5x plus 6. Now, if I were to look at that, it's non-monic because it has a negative coefficient of x squared. And that makes it a little bit difficult to, first of all, I can't complete the square with it. And second of all, it makes it a little bit tricky to factorise. In fact, it's not possible. So the only option I'm left in order to solve it is to use the quadratic formula. So first of all, I want to know how many roots there are and if it's worth me using the quadratic formula. So I'm going to check the discriminant. Now you notice that I've circled or made clear that according to standard form, A would be this negative or -1, B would be this -5, and C would be +6. So often people forget about the negatives, so really do try and get that correct. So the discriminant, the formula for the discriminant is b squared minus 4ac. And we want to substitute in carefully with that. So b is -5 squared. Take away 4 lots of a, which is -1, and c, which is 6. Now, because I found that the discriminant was 49, that meant there were 2 roots. So I can go ahead and use my quadratic formula in order to find out exactly what they are. So again, substituting carefully, negative of -5 plus or minus. We're going to use that answer we came up with, save ourselves a little bit of work, over 2 lots of -1. So negative of -5 is 5, plus or minus square root of 49 is 7, all over -2. So I can say x is equal to 5 plus 7, which is 12, divided by 2, which is -6, and 5 take 7, which is -2, divided by -2, which is 1. So next I need to find the axis of symmetry, because this will help me find the turning point. And I'm going to use my little formula, or I could just add the 2 numbers and divide by 2. It's up to you. Negative b over 2a. So negative b, so negative of -5 over 2 lots of -1. We've got 5 divided by -2, which is -2.5. Once we've got the axis of symmetry, what can we find? The turning point. We're going to substitute that value into the original formula. So we had y equals negative x squared, take 5x plus 6. Let's put that -2.5 in all of those, oops, I forgot the negative, in all of those places for x. Use your calculator. So we've got -2.5 squared, take 5 lots of 2.5 plus 6, and I get 12.25. So my turning point occurs at -2.5, 12.25. The last important point to find is my y-intercept, and that always happens when x equals 0. So y equals -0 squared, take 5 lots of 0 plus 6, which equals 6. Now after these 2 examples, you might have noticed that the y-intercept actually just happens at whatever c is, because once you substitute those x's equal to 0, that's all you're left with. So here we go, now we can sketch a graph. So here's my Cartesian plane. Remember to use a ruler for that. Apologies that I'm doing that freehand. And then we want to slowly move our way. So we've got one root at -6 and one at +1. Our axis of symmetry is -0, 2.5, and we have a turning point at 12.25. And I've got a y-intercept at 6, so about halfway between there. Now you'll notice that this time around we've got our points here, turning point here, which means we've got a maximum value for our quadratic function. Okay, or we have an upside down or a sad face. All right, now the reason this happens is because that coefficient was a negative, and that's what made that happen. Now I can just pop in those important pieces of information, label them, and I am complete.